All right, let's go ahead and get started. Today we will continue talking about pandas. Again, pandas is an important package or module that we use in Python for giving us the data frame. So, anytime you have tables of data, kind of these, if you think about a two-dimensional table, a data frame is often the kind of data structure that comes to mind. And a data frame consists of columns, and those columns will each be of the same data type. And the way pandas works is the columns are constructed out of NumPy arrays. And we know NumPy arrays are values of the same data type. And so basically, pandas data frames are these NumPy arrays, kind of tied together. One thing about pandas is that every column, all of the pandas series, which is what the columns are, they all come with an index. And pandas data frames also come with an index. And so on Friday, when we first introduced pandas, we saw a little bit of, constructing a data frame, and we saw a little bit of kind of like working with the index. This concept of an index is very important to pandas, and there's a lot that kind of derives and develops from it. So today we will focus a lot on that indexing feature of pandas. Okay, so in our notebook, we're going to import NumPy, and we'll import pandas. And again, the convention is to import NumPy as NP and pandas as PD. It's not a requirement, but people will have a harder time reading your code if you don't follow the convention. So here I am creating two series, okay? One series, the values are in numeric order from least to greatest, 1.4, 2.3, 3.1, 4.2, okay? The value after the decimal, the 0.4, the 0.3, the 0.1, the 0.2, will correspond to the index, okay? So the 0.4 is a D, the 0.3 is a C, the 0.1 is an A, and the 0.2 is a B. And this will just allow us to kind of see how the indexing is working along with these numeric values and things like that, okay? Something similar going on here. This one's not in order. 2.2, 3.1, 1.3, 4.4. And again, the 0.2 is a B, the 0.1 is an A, the 0.3 is a C, and the 0.4 is a D, okay? So we've got that. All right, so here when I just kind of, here's my series, and I say, hey, print out the series, it is created. It prints out in the order that I established it. So index was DCAB, and it creates DCAB, all right? Okay, this time though, I'm creating a data frame by joining these two series. And we had a few options for creating data frames. One way to create the data frame is to produce a dictionary. A dictionary for, we've got column 1 is X, and it's going to contain the values in original 1. And then I have column 2, X2, and here, I have, I'm going to do original 1 times 2. So basically the same thing. And because both of these things are in the same order, DCAB, okay, this will create a data frame with the index in DCAB. Okay. Original 2, though, is the other series that we've created, okay? And this one is in the order BACD, okay? And so if I create a data frame here, where I'm combining X as original 1 and Y as original 2, because X is in the order DCAB and Y is in the order BACD, and these indices are in different orders, Pandas is going to align all of these things, okay? And then it will arrange them by default by ordering the index. And the default ordering will be alphabetical, or if it's numeric, it'll put in numeric order. So it's going to go 3.1, 4.2, the 0.1, 0.2, 0.3, 0.4s, okay? It aligns those, okay? If you ask what is the index of original 1, it retains its correct original order of DCAB. And then if you subset original 1 from, and you say, I want to slice from D through A, okay, it's going to subset in that order, DCA, okay? Whereas if you ask, what is the index of this thing, DF, the index is going to be in the order ABCD, okay? And therefore, when you slice from A through C, it's going to slice in that order, ABC, okay? So depending on how you're dealing with things, if you're dealing with kind of just like, so one thing where it's easy to get mixed up, okay, is you might assume that like, because this column contains a particular series, when you work with this series, you might, in your head, think it's in this order A, B, C, D, okay? But if the way this data frame was constructed was out of kind of different series that might have been in different orders, and then it got realigned, you could run into an issue. One way to kind of avoid that is, once you have your data frame, you can say, hey, I want DFX, right? And DFX will pull out that column X in this particular order, A, B, C, D, right? So I guess you run into problems if you try to keep track of too many things in your head, okay? So it's always kind of better. I always recommend, especially if you're working in a notebook, just kind of like print out the data frame, or if you're going to start working with one of the columns or work with just one of the series or something, just like print it out briefly and just say like, okay, this looks the way I think it's supposed to look, and then I'm going to do operations on it so it works the way I think it's going to work. Okay. You can take values in a series or a data frame, all right? And both series and a data frame have this method called sort index or sort values, right? So here's the series, and again, the index is not in order, BACD, the values are not in order, okay? And so you can say, hey, take that thing, original 2, and sort it by index, and it will sort everything by index. So the index is ABCD, okay? Or you can say sort by values, okay? And now the values go from least to greatest, 1.3, 2.2, 3.1, 4.4. The index reflects that, CBAD, so on and so forth, okay? Here's the data frame. The data frame, the index is already sorted, ABCD, but you can say sort by values, okay? Now you have 2 columns of values, so you can say, hey, I want to sort values based on column X, and you can also provide extra arguments. You can say ascending equals false, so that will put it in descending order, okay? And so it has sorted X, 4.2, 3.1, 2.3, 1.4. You can say, hey, sort by Y, okay? And it does, it rearranges them as necessary. So you got dot sort values, dot sort index. The data frame here is already sorted by index and things like that. Okay, let me, you know what? I have to load it up. Okay. Well, as that loads. Okay. You can also change the index, okay? Now there are, so one thing is that the index in a Pandas series or data frame is immutable, okay? You cannot modify an index once it's already established. Okay, but if you want to, sometimes you do actually want to change the index. So the only way you can do this in Pandas is you can't just modify, you just create a new index and you replace the old index. Okay, so you can't, so like a tuple, once it's created, you can't just say like, hey, swap out the third value for something else. But what you can do is you can create a new tuple and replace the other one. Same thing with an index. You can take the, so here's our current original one. The index is DCAB, right? It's in the order 1.4, 2.3, 3.1, 4.2. I can take the index, original one.index, and just set it to a range 4 object, okay? And if I do that, okay, now the index is 0, 1, 2, 3. Okay, we have just replaced the other index. Okay. If I ask what is the index is now a range index. Start 0, stop 4. Okay, and then if I ask, okay, original 1, square bracket 1, if I subset to 1, what is this going to return? It's going to return that value 2.3, right? Okay, it's going to return the value corresponding to index 1 there. Okay, and then so if I do .loc is going to give me the value corresponding to index position 1. Okay, and then .iloc and loc are going to have the same behaviors here because iloc assumes a range index that starts at 0 and and that's what we have, a range index that does start at 0. So loc and iloc will have the same behavior there. Okay. Now here, I'm going to just replace the index again. Okay. So original 1 right now, its index is 0, 1, 2, 3. Here, I'm going to just create a new range index that starts at 1 and ends at 5, 1 through 5. Okay. So 1, 2, 3, 4. And I'm going to just replace the index. So you can just replace indices, all right? That's fine. You cannot modify them, but you can replace them, and that's different, okay? So now original 1 looks like this, 1, 2, 3, 4. Okay, what will square bracket 1 return? Original 1, square bracket 1. 1.4 or 2.3, what do you think? All right, so this is something you like. I mean, I haven't written the final exam, but you got to know the answer here, okay? You're gonna get back what corresponds, okay? So this, we'll look at the index, you'll get the 1.4, okay? The .loc, what will .loc do? 1.4, okay? What about .iloc? iloc will be 2.3. Okay, iloc always has a zero-based index. Okay, and so this will give us 2.3. So so this is important. Okay, this is at least Pandas functionality. All right, so make sure you understand what's happening here when you have a range index that starts at 0, and what happens when you have a range index starting at 1. This is a common thing that you run into in Pandas, especially like if you import a CSV and there's already a column and you say, hey, we're going to set the index to this column. Sometimes those columns will start at 1 rather than 0. And you're going to have, things running off of this index. It's totally fine, no problem, okay? But .loc and .iloc will have different behaviors, and you just have to kind of be aware of that, okay? If I say square bracket A, okay, square bracket A, there's no A anymore, right? This is my series, 1, 2, 3, 4 in my index. I don't have an A. Way back here, I created the thing with A, B, C, D, but that's gone. I replaced that index, okay? And so now we're trying to use these names that don't exist anymore, okay? And this is the error. You get all kinds of stuff comes back. You get key error A. Key error A. Basically, that value doesn't exist, right? Because it's part of Pandas, the error message is looking at all of these different sections within the Pandas code, okay? And so this part, a little bit harder to parse, okay? But key error A tells me that key doesn't exist as far as the thing goes, okay? Okay, here I'm gonna go back. I'm gonna replace the index. I'm replacing it with a new index, okay? With letters, A, B, C, D, okay? Now, again, with Pandas, there's no restriction as far as what the meaning of the index is, okay? This doesn't matter to you because we were just making up arbitrary numbers that had no meaning and stuff, right? But if your original data was state information, okay? Let's say you downloaded this from Wikipedia and you had and it's in alphabetical order, so that's what Alabama, Alaska, Arizona, et cetera, goes like that, okay? And then you have another thing, and you have kind of the list of states, but maybe they go in a different order, okay? Maybe they go in order of like population, California, Texas, I don't know what the next biggest state is, New York, Florida, something, okay. You know, what do we do, okay? Pandas doesn't know, Pandas doesn't care. It just says, oh, you want to replace the index with ABCD? Fine, okay? ABCD, here's your index. A is 1.4, and when I go original A, it gives me back 1.4. Remember when we first established the index, we said the 0.4 was the D, and the 0.3 was the C, and the 0.1 was the A, and the 0.2 was the B, or whatever, okay? That whatever information is lost because I just said, hey, here's a new index, ABCD, use that, okay? Pandas is just like, okay, ABCD, that's how it goes, all right? And we've renamed the things, basically, okay? This might feel a tiny bit wonky, all right? But here, now that I've got strings as my index, I can do square bracket, quote A, and I'll get back 1.4. Okay, I can now do square bracket 0. Okay, square bracket 0 will return right now 1.4. Now I get a warning. Okay, it says, you know what, this can be a little bit confusing, so we're going to get rid of this this behavior. Okay, so get item treating keys as positions is deprecated, okay? Integer keys will always be treated as labels, okay? So that's just a warning. Right now it works, in the future it won't, okay? If you try to get something like, if you try to replace the index, okay? Here I'm giving it 5 values, 1, 2, 3, 4, 5, and we only have, 4 values, A, B, C, D. Here, if I try to replace it, it's going to say you can't do that. Length mismatch. The expected axis has 4 elements, saying like your thing only has 4 values in it. Okay, so we're expecting something with only 4, and you gave me 5. All right, so that's what we have. Okay, here's the data frame. You can also just replace the index of a data frame. We have JKLM here. That works fine. With data frames, the data frame you can't, so I can do J here. Oops. Oh, no. You can get that, and let me see. Yeah, with a data frame, you can't go index positioning here. Okay, let me see. .iloc will work, but .loc position 0 will not work. You got to provide the and it is case sensitive. So if I try a capital K, it's not going to work, but lowercase will, so on and so forth. Okay. All right, we have, there's okay, wait, I have to give you let me give you your first view quiz answer for today, which is the letter A. Okay, A as an apple, A as an apple. We have another, thing that we can do with indices in pandas, and that's called re-indexing. Okay, so I've shown you where we've changed the index by just kind of creating a new index and replacing the old index. So that's one thing. There's something called re-indexing, which sounds like, oh, I'm changing the index, but it's not the same thing as just creating a new index and replacing the old index. Okay, re-indexing takes a current pandas object, either a series or a data frame, okay, and creates a new object that conforms to the new specified index, right? And I wrote, do not confuse re-indexing with just creating a new index and basically replacing the old index. So I think this will make most sense if I just show you examples. Okay, so here, again, here's my index. We're going to call this original. And again, I've got the 0.4, 0.3, 0.1, 0.2 corresponding to DCAB. Okay. I remember when I tried to create a new data frame back here, when I wanted to create a data frame where I had like the different, or I replaced the index where I had different number of elements, 1, 2, 3, 4, 5, I got an error and said you can't do that. Okay, you can do something like that with what we call re-indexing. Okay, so here re-indexing, I'm going to provide a new index, A, B, C, D, E. Okay, and it's going to take this thing and it's going to create a new object that conforms to this index that I've specified, A, B, C, D, E. So it's going to align the existing things, and then when it doesn't, when it finds a value that it doesn't exist, it's going to just kind of create a NA for that thing. So here is what we get. So it has taken the kind of original thing and I re-indexed it, and so the new object conforms to the index that I provided, A, B, C, D, E. So I get 0.1, 0.2, 0.3, 0.4, and then I said, hey, I want an E. And it says, I don't have an E, so it puts in a NaN. Okay, so this is re-indexing. It is taking this and it's conforming it to this and it's doing the best it can. And if it can't find something, it puts in a NaN. Now, if you don't want NaN, you can specify a fill value. You can say fill value equals 0 or whatever you want. Okay, and it has the same behavior, except instead of NaN, you get a 0. Okay. All right, so here I've got a data frame, blue, purple, yellow, okay? And the index values are 0, 3, and 6, okay? And all right, what's gonna happen if I do re-index range 9? So range 9 goes 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So the blue gets aligned with the 0, purple gets aligned with the 3, yellow gets aligned with the 6. We have a whole bunch of things that didn't have values, so those get filled with NaNs. Okay, so that's re-index. Now, what you can do is you could replace the NaNs. You can put in a fill value, and you can say, hey, I want to put in 0 or put something in for all of these things. Okay, for something like this, you can do something called forward fill. Okay, with forward fill, it's going to say, here's blue. And then for the 1 and the 2 that come after, we're going to push those values forward. So it'll go blue, blue, blue. And then the next thing is purple. And then we have missing values. We don't have anything for 4 and 5, so we'll push purple forward, so on and so forth. So the NaNs here get filled in with blue. The NaNs here get filled in with purple. The NaNs here get filled in with yellow. So that's forward fill. Okay. You have the opposite called backfilling. Okay. So it just works backwards. And so basically the purple will get filled backwards into positions 1 and 2. The yellow will get filled backwards for positions 4 and 5. Okay, we don't have anything for 7 and 8. Nothing came after that. If we had something at position 9 or whatever, that would get filled back. But this would be filling in, our missing values with backfill. Okay, so we have forward fill and backfilling. Okay, so these are, these can be handy, especially when you're filling in some kind of time sequence or something like that. You can also create date ranges and use those as indices. So this is especially useful if you have any kind of time series data, stock market, this and that, stuff like that. Okay, so you can create a date range. Okay, so you just specify, say, a starting date. We'll say January 1, 2010. Okay. periods equal 6, frequency D for daily, okay? And when we do that, it will create a date time index. 2010 January 1, 2010 January 2, 2010 January 3, so on and so forth, 2010 January 6, okay? Here I'm just making up arbitrary prices for some mystery product, and we're gonna specify the index to be the date index that we created back here, okay? So the PD date range is gonna be my index, and so here I have this, and I've got a column of prices, 100, 101, NAN, 100, 89, 88. Okay. I think this is just duplicate code, right? Yeah. I don't know. Somehow I messed that up. Okay. I'm going to create another index, okay? Here I'm going to start a few days earlier, okay? In December 29th, 2009, okay? So remember, our thing started 2010, January 1, and we start a couple days earlier, the 29th of December, okay? And so if I say, hey, re-index this thing to conform to this, okay, so this goes from the 29th to January 7th, then basically it aligns the values just like this, and then we get NANs basically for all of the other dates that we didn't have, okay? So if you do say B-fill, backfill, this value 100 will get filled backwards, okay? But backfill will not take this value and replace this 103 because this this value right here in January 3rd, this NAN was part of the original data, okay? This is not a NAN that was induced by re-indexing, okay? So when we re-indexed, it introduced these NANs in the 29th, 30th, and 31st, okay? And so using method backfill is going to take this value from the first and backfill those dates, okay? But it's not going to backfill this one because this NAN was not introduced there. Okay, so that's re-indexing. Now, if there is nothing, if you don't have any missing information, re-indexing and .loc will actually work kind of similarly, right? If the new index, however, has values that don't exist in the current index, then you will need to do re-index. So here's a data frame, again, DCAB for my things, and I can say, hey, re-index, so it conforms to ABCD, all right? And it does that. But look what happens if I do .loc, okay? .loc, and I say, hey, give me the things that correspond to ABCD. These two results look almost this, I mean, they're identical, okay? These two results are identical, okay? However, if you have something where you have a key that doesn't exist, like E, the re-index will introduce NANs in those places, whereas .loc will return an error, okay? You'll get a key error. E is not in the index, okay? As we would expect. So, so anytime you're going to have where you think this could be a situation where there's going to be some kind of index value that doesn't currently exist, but you still want it to kind of conform, and you're okay with the introduction of NANs, or you're going to use a forward fill or backfill method or something, that's when you use re-index. If you're just kind of looking for values that already exist and you know you're not looking up anything missing, okay, then you can do .loc, right? Sometimes you want the error. You want to say, hey, I want to locate all of these things, and you put in the E, and you're not quite sure if it's there or not, but you don't, you want the error message if it's not there, okay? And so .loc will return the error message if it can't find the key. So sometimes you want that error message so that is brought to your attention that like, oh, I'm asking for something that doesn't exist. Okay, let me give you your second answer today. Second answer today is the letter E. E as in elephant. Okay, you can get rid of rows or columns using df.drop. Okay, df.drop will drop rows, or if you specify columns, it will do that. Okay, so here I've created a data frame. I've just got the rows. Row index is XYZ, column index is ABCD, okay? I can do df.drop X and Z. I'm gonna just delete those rows. I'm gonna delete the row X and Z, and I'm left with a data frame with just row Y, okay? If you wanna get rid of columns, okay, then you have to specify axis. Axis equals 1. So by default, it's axis 0. But if you specify axis 1, then it'll look for columns. If you don't specify axis 1, okay, then it's going to say, hey, I couldn't find B and C. Okay, B and C not found in the axis because it's assuming axis X is 0. Okay, same error here. But if I say, hey, look for axis 1, okay, then it gets rid of columns B and C, right? Okay, now when you call df.drop, it doesn't modify the original df. The original df remains the same. It just returns a new object, okay? New object. If you want to work with this thing after you've dropped things, you got to save it somewhere so you can kind of work with it, okay? Now, if you want to replace it, there is an optional argument, in place equals true, and that will just modify, you delete the rows, it'll modify the data frame in place, okay? But the default behavior is that this original data frame is unmodified and it's returning a new object. Okay, so this is when you do arithmetic with a data frame, it will always align the indices. Okay, so here or with a series or things like that. So here I've got a series. This series has index A, C, D, E. There's no B. Okay. This one has index A, C, E, F, G. Okay. There's no D. There's no B. Okay. And here I'm going to make a data frame with series 1 and series 2. Okay. So here it creates a data frame A, C, D, E, F, G. Okay. There's no B still, but it aligns everything else. Okay. And so our total index has A, C, D, E, F, G. Okay, so what happens if you do series 1 plus series 2? Series 1 plus series 2. Even if you don't create this data frame, Pandas always uses the index to align the values for your things to go. Okay, so when you do series 1 plus series 2, it's going to say, all right, we're going to do A 7.3 minus 2.1, okay, and we get 5.2. Then it aligns the C, and we get negative 2.5 and 3.6, and it does that, okay? The D, we have a 3.4 and a nan, okay? So when you try to add those together, you get nan, okay? The E's, we have a plus and minus 1.5, so those cancel out. And here I've got a nan and a nan, so we have that, okay? So that's if you just use the plus operator, okay? You can also do s1.add s2, okay? And you get the same thing. And I think, is it nan-add? No. Oh, okay. So you can do add s1, add f2, but you can also do fill, I think, equals 0, all right? No? Oh, fill value, sorry. Fill value equals 0, all right? And what that will do is, where it's a nan, it's going to just fill in as 0. So if you do S1 plus S2, that D, it'll be 3.4 plus nan, but that nan gets replaced with a 0. So you can do S1 dot add, okay? If you want to do something like that. Otherwise, when you try to add an value with a nan, you're going to get back nan. Oh, and I have the same kind of thing. So you have subtraction, same thing. S1 subtract S2, okay? Fill value equals 0, and it does that. You also have R sub, okay? R sub means right-hand subtract. So S1 minus S2, you know, you do 7.3 minus 2.1, and you get a minus a negative 2.1. So you get a positive 9.4, right? Negative 2.5 minus 3.6 gives us negative 6.1. If you do right-hand subtract, okay, S1 R sub S2, it's going to do S2 minus S1. So basically, we're going to get the negatives of the previous thing, okay? So we're going to get negative 9.4 and positive 6.1, okay? We're doing the right-hand side minus the left-hand side. So that's what R sub is. Same kind of thing. Multiplication, you have, you can do star, and it will do element-wise multiplication. It will line up the A with the A and the C with the C, and so on and so forth. If you want to handle the nands, you can do fill value equals 1 or something for multiply, okay? And you do S1 dot multiply, so on and so forth. Okay, if you have data frames and you have columns and rows, arithmetic with the data frames will also align the rows and the columns accordingly. So here I've made up 2 data frames, okay? I've got rows Ohio, Texas, Colorado, columns B, C, D. Here I've got Utah, Ohio, Texas, Oregon, okay, and columns B, D, and E for data frame 1 and data frame 2. Okay, what's going to happen if I do data frame 1 plus data frame 2? Okay, it's going to align up the columns, and it's going to look for, okay, we got column B and column B, column D and column D, okay? It also has a column C and column E, and it's going to align those, but we got NAs, right? It looks at the rows, it tries to align those. We got Ohio, we have Texas in common. So, so when we do this, the result, we get a whole bunch of nands, but that's exactly what we asked it to do, right? So we have a value for Ohio B and Ohio B here. So the 0 plus the 3 gives me a 3. The Ohio D is a 2, and the Ohio D here is a 4. So we get a 6 there. But basically, we don't have anything for the C or the E, so those get nands. Okay, we have values for Oregon here, but not up here. So so we get nands there, and so on and so forth. So we really only have 4 values and everything else is a nand. So that's DF1 plus DF2. Okay, it aligns everything up. Introduces nands where it couldn't figure it out. Okay, if you want, you can do fill value equals 0, and again, instead of nands, it'll fill in the nands with zeros, and it will add it to the other things. So you know where it has Utah D, and we don't have anything Utah here, you know, at least we'll get a value here. So when we do that, we get you know, Utah D is 1, and so on and so forth. There's still a few nands because there's no Utah C in either of these places, right? We don't have a Utah C. We don't have a Utah C. So there's still some nands, but you know, everything else got kind of filled in that way. Okay, all of the different things that you can do as far as arithmetic with data frames in series go is you can do dot add, dot subtract, dot multiply, dot divide, okay? And you have dot, you know, the right-hand versions of these things. I don't know if there's a huge difference between right-hand add and regular add. It feels like they're the same, but there might be a case, okay? And then you have floor division and power for exponentiation. So basically your basic math operations or basic arithmetic operations that are available in Python are available here as well. Okay, you can also get summary statistics for a data frame. Okay, summary statistics including things like sum and mean, stuff like that. So here I've created a data frame. I've got a column 1 and a column 2 and index A, B, C, D, E, F, G. Some of these things have nands. Okay, So when you do df.sum, okay, it's going to return column sums, and by default, it's going to skip the zeros, so we get a sum for column 1, 1.5 plus 6 plus 1.5 plus 4 and 6, that adds up to 19. Here I get negative 4.5, negative 1.5, negative 4.5, and positive 4, I guess adds up to negative 6.5, okay? Here's our reference here. You can specify, I want to sum axis equals 0. I want to sum across the rows, okay? So now you will get 1.5, and again, the sum ignores the nands, okay? So we get a 1.5, 6 minus 4.5 is 1.5. All right, I guess it fills in zeros for nands. Okay, so zeros is that, 1.5 minus 1.5, 0, 4.0 and 0 is 6 and minus 1, so we get this, okay? If you say skip NA equals false, then it's going to say, well, you have nands, so I can't, the total sum for the column is missing, okay? Similarly, you can ask for the mean for the column. And let me just double check here. The mean is 3.8. So what is that? That's 19 divided by 1, 2, 3, 4, 5. Yeah. So it skips the nands when you ask for the mean. It's not replacing the nands with a 0, okay? But it's just skipping them. So you're getting 1, 2, 3, 4, 5. 19 divided by 5 is 3.8. Okay. Mean for the axis. Axis equals 1. You know, what's the average of these two things? And so with C, with two nands, the mean there is going to be nan. You can ask for the minimum, and it will give you column-wise minimums. Okay. You can ask for the maximum, so on and so forth, okay? IDX min, okay? IDX will give you the index of the value that corresponds to the minimum. If there's a tie, it's going to give you the first instance of it, okay? So in column 1, the minimum value is 1.5, and what is the index of the row that corresponds to 1.5? A, okay? For column 2, the minimum value is negative 4.5. And what's the row that corresponds to the minimum value? Row B. Okay? And, you know, even if we have a tie, it just gives us the first instance there. So that's what we have there. Okay? These are some of the different values that are summary stats that you can do. So you can ask, we saw asking for the mean and the sum. Okay? But you can also ask for the count or the median, variance, standard deviation, so on and so forth. Sometimes you want unique values, okay? So here's our data frame. You can say, all right, in column 1, so I'm going to do df.1.unique. This will give me the unique values in column 1, and it gives them in the order observed. So it starts off at 1.5, then it says we encounter a 6, then it encounters a nan, then it encounters a 1.5 again. That's not unique. So it goes to the next 4, it encounters a 6, and a nan. Those are not unique, so this is the result. Okay, column 2, similarly in the order that we observed them. At nan, negative 4.5, negative 1.50, and then positive 4. Okay, df.unique can only be applied to a column, one series. You cannot ask for what's the unique in the entire data frame. Okay, so there's no df.unique. You can ask for the number of unique values, and this will be the number of non-missing. So nans don't count as unique values. So when you do df1 unique, there's 4 values here, but one of them is a nan. So we have 3 non-missing unique values. So nans don't count towards the thing of n unique. Okay, and then you can also do value counts. Right, and this is kind of like tallying up how many times a particular value appears. So it's kind of like saying, hey, go through and tell me, like, how many times do 1.5 appear? How many times did this number appear? And so that's dot value counts. This is a good one to keep in your mind and have in your back pocket, because sometimes you're like, oh, I want to do this, and you just you're like, oh, okay, dot value counts for this column. Okay, you can check if you can get a logical value or a Boolean value. You can see if a particular value is one of something. So you can do df.1.isIn, and you'll get true or false. Is it one of those things? Okay. So that's the preferred thing. If you tried to do something like, so don't do this. df.1 equals 1.5 or 4.0, okay? Don't do this. How do I write this? Okay? So this, well, okay, you just get an error here, okay? If you want to do something, you can do df1 equals 1.5 or df1 equals 4.0, okay? And you'll get back the same thing. The dot is in, this is the much better way, okay? The Pandas knows people want to check something like this, and they have a built-in function, all right? Use the built-in function, the dot is in, okay? You can also kind of, if you want to filter out those things, like you like not in, all right? We don't have that, okay? But you can, you can do a bitwise replacement to get, say, I don't want those things, okay? So you can do it that way. And then you can filter out missing values. So you can say, all right, we got missing things, okay? Drop NA will drop any row that has an NA, so it'll drop A, C, and G, okay? Or you can say, only drop the rows where the entire row is missing. So you can say how equals all, that will only drop row C, okay? Or you can specify just on one of the columns, okay? You can do df subset the data frame, so df2 is not null. Okay, and then filling in the missing values. So if you have the data frame, you can fill in the missing values with a specified thing, like 0, all of the missing values. You can also fill in like column 1 gets 1,000, column 2 gets 0, or something like that if you want to do it that way. You can fill in backfilling. I guess that's going to be deprecated. Okay, you can calculate the mean of a column, and you can fill in the values with the mean as well. Okay, so you can see 1.8, 3.8 getting filled in there. And then you can transpose and things like that. Okay. If you want to fill in with like the mean of the row, this is a little bit of trickery here. You have to kind of transpose it, calculate the column means that way, fill them in, and then transpose it back if you want them to fill in the means, okay? And then finally, you can deal with duplicates. You have duplicated rows, so if are any of the rows duplicated, row F is a duplicate 6.0, negative 4.5, 6.0, negative 4.5, that recognizes that's a duplicated row. So you can get rid of duplicated rows, okay? You can also ask, are any of the values in column 1 duplicates, okay? So .1 duplicated D, F, and G, as far as column 1 goes, D, F, and G are duplicate values from before, and you can filter out as necessary there. Okay, we'll wrap things up there, and I will give you your third view quiz answer.